Have you ever driven along a winding mountain road? Sometimes you're climbing uphill, sometimes you're racing downhill, and every now and then, you reach the very top of a hill or the bottom of a valley before the road changes direction. In this video, we're going to use that road trip to understand one of the most important topics in calculus, differentiation. By the end, you'll know how to measure how steep any part of the road is, find the highest and lowest points along the journey, and understand why the road changes the way it does. Imagine you're planning the ultimate road trip through the mountains. Looking at the map, you can see the road twisting, climbing, and falling. If someone asked, "How steep is the road right here?" just looking at the map wouldn't give you an exact answer. You could draw a tangent line to estimate the steepness, but that's a bit like guessing how steep a hill is from a photo. You'd be close, but not exact. That's where differentiation comes in. Differentiation tells us the exact gradient, or steepness, of the road at any single point. It's like having a smart GPS that can instantly tell you exactly how steep the road is wherever your car happens to be. The rule itself is surprisingly simple. Whenever you see a term that looks like a times x to the power of n, you can find its derivative by calculating a times n times x to the power of n minus 1. Think of it as your GPS calculating the steepness of every section of road. You simply bring the power, n, down to multiply the coefficient, a, then reduce the power by 1. The notation for this gradient function is dy by dx, which is read as the derivative of y with respect to x. Throughout this lesson, you can think of dy by dx as your road's steepness indicator. Now, imagine you're driving higher and higher until you reach the very top of a mountain. For one brief moment, the road becomes perfectly flat before you begin driving downhill. That perfectly flat point is called a stationary point. The same thing happens at the bottom of a valley. As you drive downhill, the road eventually becomes flat before you start climbing uphill again. These are exactly the points we're looking for in calculus. To find them, we simply set our steepness indicator, dy by dx, equal to 0, because a completely flat road has a gradient of 0. Then we solve for x. Once we've found that position on the road, we substitute the value back into the original equation to find the full coordinates of that point. But here's the interesting part. How do we know whether we've reached the top of a mountain or the bottom of a valley? We look at what the road is doing just before and just after the stationary point. If you're driving uphill, then the road becomes flat, and then you start driving downhill, you've just crossed the highest point on the journey. In mathematical terms, the gradient changes from positive to 0 to negative, so the stationary point is a maximum. If you're driving downhill, then the road becomes flat, and then you start climbing uphill. You've reached the lowest point of the journey. The gradient changes from negative to 0 to positive, so the stationary point is a minimum. There's an even quicker shortcut called the second derivative test. Imagine stepping back and looking at the road from a helicopter instead of sitting inside the car. Instead of asking, "How steep is the road?" you're now asking, "What shape is the road?" To answer that, we differentiate one more time to find d squared y by dx squared, called the second derivative. If the second derivative is positive, the road curves upwards like the bottom of a valley, so you found a minimum. If the second derivative is negative, the road curves downwards like the top of a mountain, so you found a maximum. So differentiation isn't just about finding numbers. It's like having the ultimate navigation system. It tells you exactly how steep the road is, where every climb and descent begins, and where you'll reach the highest peaks and the lowest valleys along the journey. If you liked this video, consider subscribing and watching the next video. Thanks for watching.